is equal A minus B complement is equals to A complement union B. First, we are going to solve the left-hand side, which is equals to the complement sign shows that we have to minus the universal set from A minus B. Then the universal set here we are given as 1, 2, 3, 4, 10 till 10, and the A minus B we are going to separate. We are going to separate A from B. So the here we, as you can see, 1, 3, 5, 7 in A set we are having 9 till 1, 3, 5, 7, 9, and in B set we are having 1, 4, 7, and 10. Here, as the 1 and 1 we are both in common, so we are going to separate that, and 3. We are not going to write the remaining elements from B set because we are separating A from B. So we are the only we numbers we write in the next set is of set A. Then we are going to separate the universal set from the A minus B. The answer, which is 3, 5, 9. Then we got the answer 1, 2, 4, 6, 7, 8, 9. Because here the 3 will be cutted, 5 will be cutted, and 9 will be cutted. So we got the answer 1, 2, 4, 6, 7, 8, and 10. Then we are going to solve the right hand side, which is A complement union B. Means we have to only my universal set will be only got minus with the set A. Then we will find the union B with of it with union B. Then the universal set as it's given 1, 2, 3. Then the continuity 10 minus 1, 3, 5, 7, 9. Here we then we are having the 1 will be cutted with 1, 2, as it's 2 remaining in the universal set. As we are minus universal set को minus करें A से, तो हम सिर्फ universal set के ही numbers लिखेंगे, A के नहीं लिखेंगे, क्योंकि we are separating universal set from set A. Then we are going to find its union with B. Here, as it's having 1 here and 2, we are going to write then 4, then 6, then 7, and then 8, and then 10. Hence, as we can see that the left hand side is equals to the right hand side. Thank you so much.
Very well done, Soha. It's very good presentation. Keep it up. You have explained very well. Now, without wasting the time, I want the other student to share the presentation. Anyone who is ready with the presentation. I want Ahad to share the presentation. If not Ahad, then Mehreen Hashmi. If not, then Asim Raza. Without wasting the time, dear students, you have to share the presentation. Now, who is ready? Yes, Ahad, please share the screen. I think Mehreen Hashmi is not here. Imran is also absent. I think he has not prepared the presentation, therefore. Imran is here. I think, Imran, are you ready for the presentation? Yes, Imran. You can share the screen for the presentation. Yes, Momina Harim, if you are ready. Okay, Ahad is here first.
Assalamu alaikum. Welcome to our presentation. I am Faik Abdullah, and today me, Ahad, and Imran will teach you question number 2 from exercise 5.3. I will be explaining part number 1, so let's get started. So, the first part in this question states that A union B union C equals A union B union C. The only difference between the left hand side and the right hand side is that in the left hand side, the one enclosed in brackets is A union B, while on the right hand side, B union C is enclosed in brackets. What that means is that when we are attempting the left hand side, we will attempt A union B first. But when we are attempting the right hand side, we will attempt B union C first. So let's attempt the left hand side first. So we will put the sets in we get this. Now we will enclose A union B in brackets, then outside the bracket we will write union C. First of all, we will take the union of A and B. The union is like the joint set of these two. A union of these two sets is these two sets combined. We get this set. This set is the union of A and B. After this, we take the union of this set with C. After making a joint set with C, the union of this set with C, we get this set. We will name it as equation number 1. Now the left hand side is solved. We move on to the right hand side. A union B union C. Note A union is outside the bracket, while inside the bracket we have B union C. So first of all, we will take the union of B and C. We get this joint set. After this, we will take the union of this set with A. After that, we get this set. We will name it as equation number 2. On comparing the left hand side and the right hand side, we see that equation number 1 is equal to equation number 2, which states that from 1 and 2 we have left hand side is equal to right hand side. Hence proved. What is proved? It is proved that it does not matter if you take A union B first or B union C. The result will be the same in the end. Now we move on to question number 2. Imran will explain to you question number 2.
Faika, thank you for the explanation of question number 1. Now let's move to his question number 2. In this question, we mainly discuss the function function intersection, which is all about taking common. In this question, we are going to take an intersection between two sets. Now, there are three main sets in this question: A, B, and C. This is another of those questions which have two sides, left-hand side and right-hand side. First, we come towards the left-hand side. It is bracket A intersection B, bracket close, intersection C. So first we will take the intersection between A and B. When we take the intersection between A and B, the answer is bracket open 1, 7, bracket close. And now we're going to take intersection between the intersection of A and B and C. The answer of that is 1. So the final intersection is 1. Now we have to prove in this question that bracket open A intersection B bracket close intersection C equals to A intersection bracket open B intersection C bracket close. In the right hand side, firstly we take the intersection between B and C as they are in the bracket, inside the brackets. Then when the intersection between them is taken, we take the intersection between them and A, intersect A. The final intersection is 1. So we prove that LHS equals to right hand side, meaning left hand side equals to right hand side. Hence it is proved. This question is really easy and not much explanation is needed for this question. Now I will leave the mic to Brother Ahad, who will explain question number 3.
Thank you, Faik and Imran. The part which I am going to solve is part number 3. States that A union of B intersection C equal intersection of A union B and A union C. It will sound complicated, so let me break it down for you. Basically, it means that on the left hand side we take intersection of B and C. We take the union of that set with set A. And on the right hand side we take the union of A with both B and C. Find the intersection of those two sets. And we will prove that these two are equal. We will divide them into the LHS and the RHS. Solve the LHS first. We will take the intersection of B and C. Common between these two sets are 1 and 10. B intersection C equals to a set of 1 and 10. And we will take union of this set with A resulting in this. Name this equation as equation number 1. Moving on to RHS. We will take union of both sets individually with A as shown here. And we will find the intersection of these sets, which is this. We will name this equation as equation number 2. Let's compare equation 1 with equation 2 to find out whether LHS is equal to RHS. As we can see, LHS is equal to the RHS. Hence we proved that A union of B intersection C equals intersection of A union B and A union C. Thank you for attending our presentation. Hope you understood all of the topics.
Dear students, I like the joint presentation a lot. It's very well done by all of you. It shows your unity and cooperation. You three have done a great job. I'm very happy with your presentation, with the concept, with the explanation, and the way that you conducted the presentation. That is awesome. Now we have here Momina Harim. She's going to explain question number 1, the first part. You have to be attentive now. Momina, share the computer original sound. Momina, if I'm audible to you, share. There is an option you can share the original sound, please. If not, then you can just turn on your mic and explain it yourself. Momina Harim, turn on your mic and explain it yourself on this board if the original sound is not played. Okay. So just go on the more option and just share computer original sound. There is an option on your screen. On the more option, you can share computer original sound. Okay, now Momina Harim, please, in the next session, I'm going to play your video myself, because right now I'm sharing the screen, so I cannot play it. Means I'm recording the video, so therefore, you can stop the screen sharing. We'll go with Asim Raza's presentation, and I will play your video myself, then fine, your presentation. Asim Raza, please have ready your presentation. As we have less time, so I want your presentation now. Yes.
Is my voice clear, ma'am?
Yes, yes, of course.
Okay. Assalamu alaikum, everyone. Today I'm going to give my presentation on question number 3, exercise 5.3. Question number 3 is, if universal set is equals to n, then verify De Morgan's law by using A is equals to empty set and B is equals to P, which is prime numbers. So first of all, as in this question, we have to verify this question using De Morgan's law. So first of all, I'll give a brief about what is De Morgan's law. De Morgan's, it was named after Augustus De Morgan's, 19th century British mathematician. It has two statements. The first statement states that if A union B complement is exactly equals to A complement intersection B complement. And its second statement states that A intersection B complement is exactly equals to A complement union B complement. Now we will verify the question number 3 using this De Morgan's law. So in question number 3, we are given with universal set is equals to n. N is the natural numbers. It's displayed there that 1, 2, 3 and infinite. Then set A is equals to empty set, and set B is equals to P, which is prime numbers. Now, first we will apply the first statement of the De Morgan's law. So first statement of the De Morgan's law is stated that A union B complement is equals to A complement intersection B complement. First of all, we will solve the left hand side, and the left hand side is the A union B complement. First of all, we will take A union B. A is an empty set, and union B, which is the prime numbers. When we will take its union, so its answer will be these prime numbers which are displayed here, which are 2, 3, 5, 7, 11, 13, 17, and etc. Now we will take, now we will, wait. Now we will take A union B complement. A union B complement, complement means whatever we set have, we will minus it from the universal set. So when we will minus A union B from the universal set, which is displayed over here, so we will have the answer 1, 4, 6, 8, 9, 10, 12, 14, 15, etc. Now the left hand side is covered. Now we will move towards the right hand side. The right hand side is A complement intersection B complement. First of all, we will take A complement, then B complement, and then their intersection. As I said, in complement, we will minus the set from the universal set. So A complement is equals to U minus A. We know that universal set is one, the natural numbers, and set A is empty set. So A complement, the answer is displayed here, which is 1, 2, 3, all the natural numbers. Now we will take B complement. It's again U minus B means universal set minus B. We have the set U universal set is equals to natural numbers minus set B, which are prime numbers. When we will minus, we will have the answer 1, 4, 6, 8, 9, 10, and so on. Now we have the answer of A complement and B complement. Now we will take A complement intersection of A complement and B complement. It is displayed the A complement intersection B complement. When we will take its intersection, so answer will be 1, 4, 6, 8, 9, 10. All the set B elements are present in set A. So we will simply write all the elements of set B, which is the answer of A complement intersection B complement. Hence, we were also having, like here, see here, we were having the left hand side 1, 4, 6, 8, 9, and so on, and we are having here the right hand side answer also 1, 4, 6, 8, 9, and so on. So hence left hand side is equals to right hand side. Now we will move towards the second statement, verifying the question number 3 of De Morgan's law. So in question number, the second statement states that A intersection B complement is exactly equals to A complement union B complement. So left hand side, first of all, we will take A intersection B and then its complement. A intersection B, A is an empty set and B is the prime numbers. So we will take its intersection, which answer will be an empty set. Now we will take its complement. As I said before, complement is the actual set minus universal set. So we will minus it. The universal set are the natural numbers minus an empty set, which are we have the answer. It's intersection 1, 2, 3, 4, 5, 6, and so on. Now we will take right hand side. Right hand side is A complement union B complement. A complement is equals to, we know that minus universal set, we will minus and we will have the answer. Then we will take B complement universal set minus B, which we are having this answer 1, 4, 6, 8, 9. So now we will take union of A complement and B complement. When we will take its union, so its answer will be 1, 2, 3, all the natural numbers. As we have here 1, 2, 3, 4, 5 in the left hand side, we have its answer as 1, 2, 3, 4, 5, 6, 7, all the natural numbers. And right hand side, we are also having its answer as all the natural numbers. Hence, left hand side is equals to right hand side. Thank you. Ma'am, I'm done with my presentation.
Okay, sorry, my mic was turned off. Dear students, Asim Raza, your presentation is very, very well done. It's outstanding. It's very well designed. The font size, the clarity,
Thank you, ma'am.
the explanation, everything was means up to the standard, up to the mark. I really enjoyed your presentation. It's very, very well done. Dear students, if you have any question from
Thank you,
Asim
ma'am.
Raza, you can ask him now. As we have less time, we have 3 minutes. So you can ask the question from Asim Raza as he has explained the De Morgan's law very well. His screen is here ready. If you have any question, you can ask him. If not, then I'm just going to summarize exercise 5.2, 5.3 here. Then we will wind up the class here as we are having just 3 minutes. Then in the next session, first we will go with the presentation of Momina Harim. Then we will start the new topic. So I want you to be punctual in the second session. Fine. I think we don't have any other student for presentation except Momina Harim. Okay, no question. Any feedback you want to give to the students who have given the presentation? Any suggestion? Any recommendation? But I want to appreciate all those two students who have worked hard and who have prepared the presentation. Especially, I like the joint presentation also given by Imran and Faik and Ahad. It was very nicely designed. Then Asim Raza's presentation is outstanding. Then by Zoha, it was very well presented. I think this all presentations are the source of encouragement for you all. So next time we will have some more students for presentation. I want to summarize here exercise 5.3. Yes, 5.3 is basically about the properties of union and intersection. We have 4 questions here. First 3 questions are means presented by you and you have well explained it. I think this is the same concept as we have done in exercise 5.2 where you are going to find the union, the intersection. And question number 3, we had the De Morgan's law, which was explained by Asim Raza, and I think it was the set of natural number. N stands for natural number. Then we have an empty set. Then we had an we can say prime numbers. So if we subtract prime numbers from the natural numbers, so just the composite numbers will be left. If you will subtract the empty set, so nothing will get subtracted and the same set will come. So it's very easily you can handle that, but there you have to be a little bit careful that which numbers will be in the sets then. Fine. So here we are done with exercise 5.3. So this is all for today. Dear students, we have 1 minute. I have a feedback from Abdullah Kamran, and all the presentations were very good, of course. Okay, dear students, that you have to be quickly, you have to join the next session. For now, we're going to stop and we are going to wind up the class. Have a nice time for now. See you within 5 minutes break then. Yes, of course, I heard why you will not receive appreciation. Even I appreciate you now. Why not? You have given very good presentation. Of course, you deserve the appreciation. Okay, dear students, stay blessed for now. See you within 5 minutes. We are going to end the meeting here.